Hello all, welcome back. And we are going to learn one of the important topic, that is the MQ cluster. And we will start from basic and go to the high level. You will make the MQ cluster. You will see how the MQ cluster work. Everything you will going to see. You don't need to worry if you have no knowledge. I will go through basic and you will get everything in deep. So for this I have made a diagram to follow this, how it's working, so that you can understand better that, and it will helpful for you. If you Let's come to basic, what why MQ cluster is required and everything. Then I will go to the diagram. First, what is MQ cluster? Let's come to the definition. A more flexible approach is to join many queue managers in dynamic logical network, that is called a queue manager cluster. And a cluster allow multiple instances of the same services to be hosted through multiple queue managers, and it uses workload balancing algorithm to split these requests across all queue managers available. It is saying that like that, it is helpful when for many queue manager I want to share a same message. I want to share a message, distribute the message between the different queue managers. Then cluster comes into the picture, and one of the benefits is the cluster is, uh, we will distribute the message in equal uh, amount. Let's explain this diagram, it will helpful. I am making a cluster. I am keeping the name of the cluster is mq.class. I am making a cluster in which I am keeping that name mq.class. Suppose application A wants to send a message, and application B wants to that receive the message. And application A sends a message in huge amount, very huge amount, and application B got to receive mainly that. So for that, if application A somehow sends a message and application B somehow is not up or down, the message will be piled to our queue, and that will be also a region that you got some memory. Other thing, that suppose, let's example, I have a somehow application A is up and application B is up, but somehow our, if the diagram is like that, let me go to notepad, it will be better understanding to you. Suppose let's application A is that, and it is going through Q1 to application B. If this is a diagram, in that case, in case let's a queue manager 1 is down, then what will happen? Application A will sends, and application B will going to not receive because this is down, and application A will not able to set because this application is already down. How can you taking like what's like let's suppose I want to do one thing. I want to put queue manager 2, queue manager 3, and queue manager 4 all in cluster. Then what will happen? In case our queue manager 1 and queue manager is down, message will transfer to application B through queue manager 3 and 4. In case of our queue manager 1, 2, 3 is down, message will send to the application B through queue manager 4. And in case all is up, message will be sent to from queue manager 1, 2, 3, 4 to application B. Why we require 4 queue manager? The first benefit is, in case any one of them is down, then it will be transferred to our application B somehow. And another advantage is, suppose application A sends 100 message at one time, it will distribute the message in equal manner. By default, it's distribute in equal manner, but if you change the distribution quantity, if you want to send say, a some percentage, then B percent, Q major 2 some percent, Q major 3, but by default is the 50-50%. So to 25 message go to Q major 1, 25 goes to Q major 2, 25 goes to Q major 3, and 25 message go to Q major 4, and it will go to the application B. What will happen that here the loads on the Q major will be distributed, so load balancing came into the picture. Are you getting my point? Here simple you can understand that if application A sends and application B receiving, and somehow if you are keeping one queue manager, then what will happen? It will, in case it will be down, it will not be received, B application will not receive, and that's the impacts our business. I mean, here we don't want to impact any business, we want to continue the business. That's the main thing. To continue business, the cluster came into picture. Cluster makes the inform load balancing. Also, in case any one of them is down, then it will continue the business, it will continue the message flow. The same thing I have understood you in diagram, where application A wants to send a message to a one of the key manager whose name is q.input, and this is distributing message to the these all four key manager in equal manner. It is sending one message to this, another message to this, another message to this, and another message to this, and after that these all sending to the application B, that is application B, it is all sending to the application B. Here why these two Q measure is required, two extra Q measure requires, these Qmax1 and Qmax2, there is what two extra Q measure is required. These are known as full repository. So why full repository is required? Why the full repository came into picture? The full repository is something Q measure that is required to store all information related to that Q measures. These four Q measures, these five Q measures, it's store the information into it. Let's go to the some more definition. The topology is especially useful in distributing the environment where capacity is scaled accommodate the current load through the multiple server rather than one high capacity server. That's the thing. And server can fail or becomes down, maintenance or service not lost. That's the same thing I told you. In case that is down, actually what is happening, this is hosting in server, different server, this is hosting distant server, this is hosting different server, and this is hosting, there is four server required for that, and these four server are different server, one queue is hosting. In case let's two server is down somehow, then service will be not impacted, service will be as it is. That's the in case I want to restart, in case I want to restart the all the queue manager, so what we will do, we will just first start this, stop and start this, rest will be as it is, then business will be not better, then we will start doing this, rest will be as it is, then we will stop and start this, rest will be at it, and then we will stop and start this. What will happen, I am starting and stopping one of the server, then rest will be working same as it is, so business will be continue, business will be not impacted. Same thing written here. Let's consider this diagram. Here what is the application A is sending some information to the from some queue manager, and here MQ cluster came into picture. What he is doing, he is sending to the queue manager 1, queue manager 2, and queue manager 3, and through it sending application message to the application Z. Here what is it is distributing the message. If you see the diagram here, if a queue manager 1 receives some information from application, quantity is 150 messages received. Due to MQ cluster, it is distributing message into 75 and 75, and after that it is getting into the services. And cluster actually works on the channel level, which for clustering MQ cluster, the channel is very important, because everything is important, everything is based on channel, so channel is very important. Let's come and told me something about the channel. For MQ cluster, how the channel configuration is made, let me little bit explain to you. For every queue managers have its one receiver channel. Keep the point in mind. Every queue manager have its one receiver channel. Okay, the two full repository queue managers have one sender channel to send information to other, and this has also one information sender channel to send information to the other. And also, why two full repositories require? Let me tell you full repository. Full repository is something like that. In case what is happening to these 4 or 5 queue manager, all information is stored in that. It can be stored in one of the queue manager. So why two we require? let's let's come and all the information that is exchanged between them, if new information come to it got into stored into that messenger, and if some extra information required to them, they will ask from them. But why two? Let's say take a scenario. In case this one is down, what will happen? Then this will help that, because whatever information is stored into that, it will be sent to that, and there is all stored into that. Are you getting my point? Simple thing is that what is happening with all the queue manager in cluster is sent to full repository, and full repository store that message. In case cluster queue manager requires some information, they will ask the full repository, and a full repository give the information to them. And we require two full repository for the safe side, because we can work with the one of the full repository. That's not a problem. If this will be not be present, then it will also work. But we keep full two repository, because in case our one of the full repo is down, then we can work with the other, and our business will not impacted. Main thing is you need to point at business should not impact. If business will be impact, then it will be a huge loss. So business will be not impact. That's the reason we keep into this into mind. Are we got to my point? Let's come to some more definition. A repository is a collection of the information about the queue manager that is a manager of cluster. A repository information includes the queue manager name and location, channels, which queue hosted information, and the information is stored in the message in the queue. If you are asking, if you told where the information is stored into that, if you the all the cluster information is stored into the already told you the full repo, and the where there is a queue system.cluster.repository.queue where all information is stored about the cluster. I already told you the two queue manager in a cluster has full repository, and others are called partial repo, and these alls are called partial because only two full repo is required, and other name is partial. Next, the a key already told you each queue manager in cluster should have a receiver channel, and both full repo need to be communicate with each other. It means full repo have receiver and sender channel. Already told you in diagram both full repo having one sender channel, and here also one sender channel. And if let's take example, if you are considering this as a full repo for this for now, then there should be one also a channel between them to pass the information to them. There will be also one sender channel between them so that it pass the information to them. Let me show you in the let me create the whole thing and show to you so that you can understand in better. I will work through this diagram only so that you can understand it better, and you will get in detail. So let me go through that diagram only. Let me our first task is application A is sending a message, and it is going to queue input queue manager. Let me create a queue input queue manager, and I am keeping the port number for this is uh, because you know that port number is very important. Port number is also listener port, we can see that, because it's used to communicate with the other queue manager. Let me here keeping, I am keeping 222 something like that. And for also for QM1 I have kept it as 333 444 555 66. You can keep any number, that's not problem, but it should be unique so that you communicate with other applications and it will be good. Let me first application is sends a message to queue input queue manager. Let me create the queue input queue manager. For creating the queue input queue manager, you have to just click on right click here, to the queue and queue input. Click on next, next, and here write the port number, what is 222. Already said 222. Click on next. What I have created, I have just application A sends information to the queue input. I have created the queue input queue measure. Next, our task is to create the QM1, QM2, QM3, QM4, so that once the message is sent come to here, it will informally distributed to this all queue manager, and message will be informally distributed to this all queue manager, and this all queue manager equal amount of message will be sent, and from there, if any application B is linked, message will go to here. But here I cannot link any application because I am working on the local host. So I can show you when application in message is sent to from this queue manager, then it will be sent to this all four, and it will be informally distributed, because I don't have a source application, I don't have a destination application, because I am working on the local host. So let's I assume that if application is sending some information to that, it will go to the these 4 kilometer, and it will be informally distributed, and it will then send application B will pick from them. So here I am going to say application when a message is sent to this, it will go to informally distributed to that. Let me I think it is created. Let me create the other queue managers. I need to create the QM1, QM2, QM3, QM4. Already I have QM1 and QM2 I have created. You can see QM1 I have created having the listener port number 333, and QM2 already have created having listener port number 4444. And other, let me create the QM3 and QM5 having port 555 and 666. Let me create QM3 having 555. You can put any number, I have just kept that. Now query being created. It will take a few seconds because some process is going in background. So till that time, please wait. Now it's created QM3. Let me create QM4. QM4. Let me click on next, 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 and let's give the 666. Click on next and finish. QM. Now what happened? Now what will be left? If you see, our once a message I will send, it will go to that. Now also for that, two full repos required to me, because I will using one full repo for them, which I will but keeps another full repo as a backup in case anything happen to this full repo. So I have to create two full repos so that if what is happening to that queue cluster, all information is sent to them, and if they require, they will take from them. And also second one, if to send them send this information to this, so that in case of any issue happen, it will we can use other. Let me create the other QMX1 already I have I think. Let me show you QMX1. You can see I have the listener port number having 1420. Let me create the QMX2 having the port 1421. QMX2. One four two one. Now all Q measure have been created as per our design. Our per design Q input created QM1, 2, 3, 4 and QMX1, QMX2. Now I need to configure to the cluster so that you can see how cluster is being created. If you see all, you can see all Q measure have been created. Let me do minimize that. You can see QM1, 2, 3, 4. QMX 1, 2, this is a full repo and there is data input queue. So once the message is sent to that input queue, it will go to that, and is there full repo to for information sharing. Let me create the cluster. You can see here the queue manager cluster. There is options. From here you can create the cluster. For that you have to click new, and then after that you can click queue manager cluster. Here you have to give the cluster name. Already I have told you that I am keeping the cluster name as mq.cluster. So let me give that name mq.clus. I am giving that name. Click on next. Here you have to simply you have to what he's saying, you have to select the first full repo of the queue manager. What is my first full repo? My first full repo is qmax1. My first full repo is qmax1. Let's select the qmax1. qmax1. Click on next. Select the second full repo. Second full repo you have to select. Second full repo. What is my second full repo? Second full repo is qmax2. Let's select the qmax2. Click on next. Create the cluster channel. Click on next. Now I have to create a cluster channel. Now I have to create a cluster channel so that they can communicate with each other. If you see here in diagram, say there is a queue measure 1 and there is a queue measure 2 and there is channel between them. This is a cluster receiver channel and the connection name is this. I told you each queue manager having one cluster channels receiver channel and there is one sender channel so that they can send information. A receiver is to receive the information. Here I am going to create a one of the clusters receiver channel for the qmax1. So what we have to do, we have to give the clusters receiver channel name and this ports number 1420, and you can see here that is the thing. Click on next. Now I have to create the if you have created the cluster receiver channel to this, then also you have to create a cluster receiver channel to this one also. Let me create the cluster receiver channel to this one also. Click. I have to just click. It's created. Let me create the finish. Let me do the finish. You can see class 1, that is the full repo has been created having the qmax1. And why this is happening, let me see. It should be not came. What is something like that system. Yeah, it's came qmax2. I think it needs to be refreshed. I have not refreshed, that's the reason it's come like that system, something like that. Now our full repository has been created. Now our task is to create the partial repository. This is the partial repository, this one. Let me create the partial repository. You have to click on MQ class. Add queue manager to cluster. You have to select. Add the queue to cluster. Let me add QM1. Click on next. How do you want? It is asking partial. You want to this is a partial repository or want to this is a full repository. So already you can see that I have already added qm1 and qmax1 and qmax2 as a full repository. Now our task is to add these as a partial repository, these all as a partial repository. I will this all as a partial repository. Then let me add these all as a partial repository. Just click on next, and also have to give the sender receiver channel. Then this is the receiver channel and let's Click on here you can see it is asking that to whom you have for this sorry for this whom do you want to give as a full repo. Why this is asking? Because if you see that if anything happening in this queue manager, the information is shared to whom. If you are giving this as a this and this, then it will use to share the information to this and this both. But for now I am keeping this one qmax1, and all information this is happening to this is happening to qm1 will send to this only. And in case anything happen to this queue manager, I will use instead of this I will use this. Why this? Because this is something somehow down, but information everything what is present in qmax1 everything is present in qmax2, so you don't need to worry about that. Let me give the qmax1 and click on next. You will just create it. Now it's finished. Now our partial repository is created. Let me refresh that. Will come. It's came. Now let me create other partial repository quickly. Let's use the other qm2. Let's click next. I will not take much time. I will just create. I am using qmax1 so that in whatever happening in this you will store to that, and click on next and click this finish. Let me create the other qm3. Next, 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 next. I am using only one. Finish. Let me choose the other. qn4. Click on next, next, next. Again I am using qmax1 as a, you can see here I am using qm4 qm also qmax1. For all q manager I am using a for all q manager 1 2 3 4 I am using qmax1 as a full repo. I am not touching this one, but in case this one is not is working, then I will use that one. Click on next. Here you have to give receiver channel name, already it is given. Just click on finish. Or all queues have been created. Let me configure the last one also to the cluster. Last one, that is the queue input. Let me replace that first. It's came. Let me go to select last one, that is the queue input. Let's keep this also in cluster. Let's click next. I am keeping this also queue. Let's click on all our images is having now in clusters. You can see here full repo is qmax1, qmax2, and the partial repository is qm1, qm2, qm3, and qm4. You can see now. Now our task is to send a message from this queue manager to this all. Getting my point? Our task is to do. So how can I achieve that? You have to see that. Let me create the queue, but before that you need to let me show you the concept so that you can understand it very easily. To send from one queue manager queue input queue to some output queue, you need to do a queue to think something basic like that. If I use a queue manager name, let's see the diagram here. If you whatever the queue name you are giving, you have to give the same queue name to these all. Are you getting my point? Here what here, if let's example here you are creating some alias queue, and whatever you will be the base object given to all four having the same base object name. So whatever the queue in present here will be same name. Why this? Because this is pointing to one of the, if I am creating one queue, one alias queue, already properties of the alias queue. Alias queue is used to point, alias queue is to point to the one of the queue. If I am creating here the alias queue and pointing to one of the local, one of the queue, or one of the queue, let's take example one of the alias queue, then message will be, so whatever one of the local queue, whatever, it don't matter. I am pointing to one of the local queue of that queue manager. Then message will be all local queue name is same because it is in cluster and it will share to them. Simple, you need to think that the queue name in the qm1, qm2, qm3, qm4 will be same, and it will be same as the alias queue name of the base object of this one. Let me first create the input, let me go to input queue. Let me create the one of the alias queue. For that, let me create the alias queue name, alias. Let me give the name q input dot alias. Let me click next. I will do the base object later. For now that, let me click the finish. Done. Let me do what I think. I whatever the base object I need to give here, that needs to be present in qm1, qm2, qm3, qm4. Already told you, already I told you ki the whatever the alias name here and whatever the base object of this should be present in that 4, because once the message is sent to the alias queue, it will go to base object and it will search for the base object. When the base object is same in all 4, it will informally distribute the message to all of them. Forgetting point. Let me create the queues. I will create the one of the local queue in all 4. Here I am going to create the qm1.local. Is it number is present? No, it is not present. Let me create the qm1.local. qm. I am going to something given name because I have to give the one queue name that is same in all 4 queue users. So let me give you something name that class.local. I will give to, let me copy that name. I will give to all 4. I have created queue, one queue here. Let me go to queue2. Also let me create here on the local queue plus.local. Click finish. Let me go to qm3. Let me create the one of the local queue plus.local and let's click finish. Let me go to queue manager 4. Let me create the one of the local queue having the same name plus.local. Then click the next and then click the finish. Now the thing is that I have created one of the alias queue name whose name is q input.alias, and I am pointing to the base object whose name is class.local, and all the class.local queue is present in one, each qm1, qm2, qm3. Once the message is sent to the queue alias, it will search for the queue class.local, and all class local is present here, then it will go to that queue. Let me point this queue whatever created to the class.local, so that once the message is sent to this, it will go to that, and this will be present in all 4. It will distribute. So, but before that, you need to think one thing, that I have created a simple queue. This queue have don't knowledge of I am in cluster or not. For that, this queue must be know that they are in cluster. How can they know that? Because our cluster, because they need to know that I am in cluster. For that, so I have to told him that you are in cluster. I have to give under each queue. I have to give the name of the mq.class. I have to give that. Let me to go to this, and this here in cluster you have to give the shared in cluster, and you have to give just name plus dot, I think it is mq dot plus, mq dot plus, mq dot. You have to click on apply and okay. Whatever what I have done, I have just told that queue that you are in cluster by putting here the name. Let me told to other queue that you are in cluster, because they need to know that they are in cluster. You have to just go to cluster, shared in cluster, and just told him that you are in cluster. Just told to other queue also that you are in cluster. Just go here, shared in cluster, and just go to cluster dot plus. Just click on apply. Just go to QM3 and just do same configuration to this also. Just set in cluster and do same work. Because I want because initially I have created normal queue and they are not aware that they are in cluster. So I need to told him so that they are in cluster by using the shared in cluster concept, because they know that I am in cluster. Now our configuration has been made. Now it's time to come the implement and see how it is working or not. Now I have to do send a message to this queue, and message will be go to this all class.local in all four queues. Let me send the message. For sending message I have to do just put text message. Let me send some message. Good morning. Now how are you all? Are you good? Hope you are fine. I just sent some message, four message. Let's see where it gone. Let me browse that queue. You can see one message has been came here. Let me browse that message. Good morning came here. You can see, let me go to that. There is one message also came. Browse message. You can see also how are you all came. That is the second message. Let me browse the other queue. Let's here. You can see here that are you good came, and let me browse that one. You can see it's came. Hope you are fine. That I have just sent four messages to these. I just sent four messages to this input queue, and these all are in cluster. That's the reason that's distributed one message to one all four queue. You can see just I just sent one four message, and these all four message distributed informally to the QM1, QM2, and QM3 and QM4. That's the concept. And now the thing is that you are sending out the how the application b. Once the application b is linked to that queue, these four message will be consumed by the application b. But you getting my point? This the concept of the cluster. Let me send more message and see how it is going on. That time I'm saying sending some more message. Let me put text message. I'm going some one counting 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. I have put 10. I have just kept thrown 20 message. See how it's distributed and how it's gone. let me that go to here, 6 messages showing. Why 6 messages showing? You must know to know. There is one message already present that I thrown. That's the I have just sent 20 messages. I just sent 20 messages to that. How it will distribute? 5 message to that QM1, how message to that QM2, and 5 message to QM3, and 5 message to QM4. It will informally distribute. You have to know. It will informally distribute QM1, QM2, QM3, QM4, and 5 message will be go to that. 5 message will go to 5, but 5 message will not go to that like that QM1 to QM5. This is 1, 2, 3, 4, 5 will go to that. 5, 4, 6 will go to like. It will not go like that. It will go one message, one get to do here, 2 go to here, 3 go to here, 4 go to here, then 5 go to here, then 6 go to here, then 7 go to here, then 8, like that it will go. You can see here, if you browse that, you write that, you can see what came here. It's 1 came here, 1 came here. Let me minimize that. You will be understand better. If you browse that, if you here ignore that message, that last time I have sent that one. Here one message came to here, one message came to here. List 2, 3, 4 will go to QM2, QM3, QM4. Then fixed message came to here. 6, 7, 8 will go to here. 9 message came to here. 10, 11, 12 go to the QM2, QM3, QM4. 13 message came to here. Next 14, 15, 16 will go to here. Then 17 message came to here. Getting my point? Next we'll go to the see how it is, how it will distribute in QM2. You can, I am telling right to you or not. You just see by your eyes. You can see 2, 6, 10, 14, and 18 message go to come here. Just see by your eyes how it is working. That's the uniqueness of that cluster. This 3, 7, 11, 15, 19 come here, and you can see here 21, 20 messages will be present there. That's the last message. Message. You can see here. That's the 20 message. You can see 4, 1, 2, 3 will go 1, 2, 3 came here to 4, 8, 12, 16, and 20 message came here. That's the it will be inform distributed. You can see how the cluster works. That's the uniqueness of the cluster, and that's it work. Hope you will understand that even better. In case any one of them are down, it will not go to that, and it will distribute it to other of the measures. In case any of the down, can let me show you by stopping one of the measures. Let me stop one of the measures. I have stopped that one. Then let me browse the. Let me clear the message in other images. Let me clear that. Clear the message. It will help you to understand it better. Message been cleared. Let me clear this also. Clear message. It has been cleared. Now let me clear into that one also. What happened here? Here a input queue is sending some information, but somehow the QM1 is down, but QM2, 3, 4 is up. The information will not be sent to this. Information will send to directly QM2, QM3, QM4, and from here application B will consume. Here what happened? Here services will not be impacted. Let's see how it is working. Let me send you message to the that queue. Again I am sending some information. Let me put information. Let me again send you some like that. A B C D E F G H I J. I have kept it till J. You can see, if you see here three message came here. Here 2 message came here, and here 2 message came here. Let's browse the queue. and see it is present or not. Browse, you can see here it's came here. You can see it's came here. It is informally distributing. You can see it is informally distributing. But here one thing I can just observe that something different. Here I can see I'm not seeing a message or no why. Let me show you here a message is not present because I have sent a message also. Let me show you. Sorry, let me browse. Here also is a not present. Somehow it is distributing equally. Let me show out why it is what is happening. It will be good to get a problem so that people can learn something. Here a not came. Oh, something is different. I am not the camera is still up. You can see here it is up. I just, instead of doing the stop, I just do a disconnect. I let me connect you. You can see here message will be there. You can see here the, if you see here the browse queue, you can see here a message is present. So I let me do the stop. I just instead of stopping, I have just do a disconnect somehow. Now it is down. You can see the down arrow is down. Let me now through some message and see how it is working. Let me through some message and see how it is working. Let me queue just queue. Let me throw some message. Now it is down. Let me browse message. Sorry. Let me put message. Let me put text message. Now it is putting it 1 2 3 4 5 6 7 8 9 10 11. Oh, 1 to 10. So 12 13. Let me browse message. Q. If you see, let me Q1 and let me go to browse message. If you see here message data 4 8 and 1 came 2. If you browse here, you can see 1 5 9 12. All message I came here. 4 message is there, 3 there, and you can see here also. You can see browse message is going to 2 6 4 8 4 4 8 and 3. It's all message came to, no message go to VM1. That's the concept. In case any one of them down, it will message will be informally distributed between them. That's the key, that's the importance of cluster. So let me brief you again. In a MQ cluster, when application A is sending a message, it will go to send application B, but somehow it is used to, it came to a queue manager, and this message will send to the 4 5 5, how many you want to achieve kept into the cluster queue manager. And cluster queue manager will do what? It will just distribute the message informally. What is the benefit of that? Benefit of that is that, benefit of this is it will workload balance, impact, server load will be decreases, workload is decreases, message will be workload on of the queue manager distributed, the risks of the queue manager crush something will be decreases. And another benefit is that in case any one of them server is down, message will go to different server and business will be not be impacted. And there will be 2 cluster, a full repository is required, the cluster full repo. Why this is required? You can use one of the cluster queue full repos with the cluster other queue managers but partial repos, but we are keeping other as a safe. because in case one of them down, server is down, you can use other server instead of that. This is the simple concept of the MQ cluster. If you have any doubt, you can drop a comment and you can comment me. I am okay to reply with your comments, and hope you enjoy this lecture, and you can comment me if you uh, happy with this lecture, then you can like the video. Thank you.